Hey guys, today I wanted to show you how to take a CSV file of about 500,000 records, in this case the Uber trip data for April 2014, and analyze it in such a way that you can get some meaningful information, um, get some patterns, and understand, like have some hypotheses and how to figure out if they're correct or not. I'll be using Python and Pandas and Jupyter Notebook. I don't want to go in detail in this video specifically over each one of those things and what is a variable, what is a string, what is a float number. However, I think even for very new people, you should be able to follow along. And by the end, you should be able to pick up some concepts and some language. I'll do later videos where I actually go and explain what is a float number and how is it different from an integer. But today I just wanted to show you how to take a CSV file and make plots. I hope you enjoy it, and please let me know if you have any question. Thank you. We will start by downloading Python. First, click on Google Chrome and write Anaconda Python, and then just click on download Anaconda now. We will download the Python 3.6 version graphical installer. Now the download is complete, we just double click on it and just press continue. Install for me only, install. Well, now that we have downloaded and installed Anaconda, we're ready to use it. To do so in Mac, we just press Command and space and write terminal. This opens the terminal where we can write Jupyter Notebook, enter. Now, this is the URL we have to go to. So to make sure that it's in a single line, I just make it a little bit wider, copy the line, open Google Chrome, and paste it there. Here we have the Jupyter Notebook file explorer. This is the list of directories in your computer, and then just press new on Python 3. This is called a Jupyter Notebook. It has some common things that you can do in the menu. You can add more cells, this is called a cell, and in each cell you can write Python code. To execute it, just press Shift and Enter. You can also use variables like this, print hello name, and this variable, once you have defined it here, is available everywhere. So I can call it here, or I can call it here, anywhere. You can cut and paste and move around. And a final very useful feature is to change from code into Markdown. Once you have it in Markdown, Markdown is a way to write documentation. So you can write, for example, like a list 1, list 2. When you execute it, it becomes a list. Or, for example, some sections for your document. So first section, second section, first subsection, and it becomes like you will expect. This is very convenient to just write yourself some notes on what are you doing and how to reproduce your data. So, okay, let's get started. We're gonna call this guy Uber Data Analysis, and we're just going to download the data from Google, actually from GitHub. We just Google Uber raw data. 538 got a foil response with some data that we can use. So click here in Uber trip data and get the April one. This is it's too big, so it won't be showing it to you. So just click Save Link As, and let's save it in the desktop. Make sure that you have the desktop selected and press Save. So here you have it. That's the data that we're going to use. So here we're going to make use of 3 libraries that come pre-installed in Anaconda distribution. The first one is all the plotting functions. So just write this code, then wrote import pandas and import seaborn. So the first one is the one that will allow us to do a lot of data manipulation, pandas, and seaborn is just a library that creates very pretty plots with very little effort. When you execute this, you're ready to do some analysis. We're going to load the data by doing pandas.read CSV, and so a useful feature of Jupyter is pressing tab. So if you write pandas dot and then press tab, it's gonna show you what are the options of things you can use. You can also, for example, do read CSV and then press !enter, and it shows you some documentation on how to use it. For example, it tells you read CSV, files into data frame, and a lot of options that you can use. So in this case, we will just we'll just load Uber raw data April 14th CSV, and this takes the file, the CSV file, and loads it in memory in something called a Pandas data frame. This Pandas data frame is an object that Python understands well and allows you to do a lot of data manipulations very easily. If you print what data is, you see this CSV, and this CSV specifically has more than 500,000 rows and 4 columns, and the columns are date, time, latitude, longitude, and base. You can access one of the columns, for example, by writing the name here. You can see here the column, and in general, since these are long data set, I'll rather just see the head or the tail, the first 5 or the last 5. That is just a little bit useful. So, like I mentioned, sometimes it's useful to add some documentation. So we will write here some hints to add for us. Load a CSV file into memory. You have to convert it into Markdown and then enter. Okay, so now that we have loaded that, we can do some simple analysis. So let's start by taking this information. So this latitude is a number, longitude is a number, but this date time is a string, meaning just text. And it should actually be in a date time format, something that Python understands that is a representation of a date and a time. So what we do usually is just convert that data to the appropriate type. Initially this will look a little bit confusing, but it's something that we do so often that becomes just normal. Pandas to datetime. So before executing this, let me show you. So if you take this text and you say datetime is equal to this, then there's not much you can do. If you want to get, for example, the date, that will be this 30 here, you'll have to first split this test by space. Then you have 2 elements. You can call it date and time, and then print date and print time. And then you can take, for example, the date part of it and split it further to its components, and then just get, for example, the first one. Or you can do month, date, year is equal to this, and then you have that the date is 30. And this quote here means that it's a string. You will have to convert it into an integer for it to make sense. So this is not too complicated, but there are some ways of doing it more efficiently and with more functionality. So what we do is we take this guy again, dt, and we use pandas to datetime dt. Now this returns something that Python understands as a timestamp, and I'm going to call it dt again. Now this dt has some nice functionalities. For example, weekday, that we have to call is weekday 2, or weekday name is Wednesday, because it starts from 0. 0 is Monday, 1 is Tuesday, 1 is Tuesday, and 2 is Wednesday. You can also, for example, get the day of the month, or the month itself, or even remember pressing tab gives you some ideas of what else you can do. So you can see here the day of the year, the days in that month, the number of hours, a lot of options you can use. In this case, for example, the week in the year, the 18th week of the year. So in order to get access to all these functions, we have to first take this string that was here and convert it into date-time format. So to do this with all our data, we just do, we take this column, datetime, and then just map it in something. Map will take a function and apply it to each one of the elements. So in this case, this is the function that we're going to be applying to datetime. And we're going to store this date time here. So this will take a little bit long in my machine. This is an old machine, so it will take about 3 minutes. But what it's doing is iterating over this list of strings that is defined by this column, the date time, and then to each element is going to apply this function. That's what map means. So it takes this element and applies this function, and the resulting date time is stored in the same that we started. So I'm going to stop here, and whenever it's finished, I'll continue. The command took about 4 minutes to finish, but now we have our data. So I will add some comments here. Convert date time and add some useful columns. Convert to markdown and execute. So can remove this guy, and now we can do data to the head. Now we have the same, but notice that it changed the order, which means it understood it. You can even date time 0, it returns a timestamp, so it looks good. Data.tail. Now we want to do a couple of analyses real quick. So something that we will do, for example, is let's let's take the day of the month. So to do so, just write a little function, get day of month, date time. Remember that you can get the day of month. Let's do this here. Date time is equal to data date time 0, and then date time date. Oh, sorry, I think it's day. It's 1, right? If you take the 500,000, it's 24. So if you want the day of the month, all you have to return is this value. So given a dt, we just do say return dt.day, and we can create a new column called date of month is equal to data date time dot map get date of month. Now, we have this DT. Let's see how it looks like. It'll tell. Yes, it got the right value. Now let's get, for example, the weekday. Data def get weekday from the date time. Return dt.weekday. Data weekday, it's equal to data datetime dot map get weekday. And then I'm going to do a last one, get hour from dt, return dt dot get hour. Data hour equals data datetime dot map get hour data dot tell. So this is going to iterate over each one of the elements in the column. This part here, it's going to iterate over each one of the elements in the column, and for each element it's going to execute this function get weekday. In this case, it's going to tell you what the weekday is, and something similar for the hour. Oh, something's weird here. Oh, you have to call it here. So we can rerun it again. And then by the end of this, we should have the hour is 23, which makes sense. The weekday is 2, because it was Wednesday. And then the date of the month is what we expected. Now that we have loaded and converted to data time and added some useful columns, we can start analysis. So analysis. We'll convert this to Markdown, and then the first thing is, for example, analyze the date of month. So far we have found the data first, then download and load the data, and massage a little bit the data into making it more useful for what we want to analyze. I would say that that's easily 30 to 40% of the work. Just taking the data, moving it around, changing its format, getting some extra data from that data. That's 80% of the job when you're doing data analysis. Another 30 to 40% is basically doing histograms, trying to understand what the data looks like. To do histograms is very simple. You say histogram and date of month, and it returns your histogram. Now there's an issue though. By default, the histogram has 10 bins, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we know that there are 30 days in a month, so we can say bins equal 30. And now we have a better representation. We have this will be the value for 1, all the way to the value for 30. Now we can see the cycles that you expect because there are weeks involved, and you can also change, for example, here the width 2.8. Oh, there is something wrong. I don't know if you can see it. That for example, you will expect it to start from 1, but it starts like a little bit off 1 and finishes slightly off 30. So to do this right, you have to move the data around and change it a little. So when I do it, just change the range, for example, 0.5 to 30.5. Sorry. And there you have it. Now we have actually the right representation that makes sense. We see that 30 is spot on in the center, 25 is spot on in the center, we can add, for example, this label date of the month, then while label frequency, then title frequency by date of month over April 2014. And that's a beautiful plot that you can actually just copy paste in your report or in your presentation, and it was very simple to generate. That's just very easy. Another thing that we can do, for example, is a little bit more complicated. Usually a lot of those is call this, for example, by date sorted, and we can just so now this hist is very powerful, very easy, but sometimes you want to do something with the data, move it around, and it gets in your way. So sometimes it's easier if you know how to just replicate this by doing it yourself, basically. So I'm gonna do a histogram by code. To do that, I'm going to use this this functionality called group by. I'm gonna group by the month, and then I'm gonna ask I'm gonna ask Pandas to group my dataset by day of month, and then it's gonna pass me each one of those chunks, each one of those groups separately, so I can process it. For example, here I can just write let me see. Oh, pandas dot data dot row is not defined because it's rows. Okay, so what happened here? This data set, remember, is the initial data set with the added column. So it's this guy that has 500,000 records. So if you're familiar with Excel, where you do a pivot table, that's something kind of similar. In this case, we just do data and group by the date of the month. So Pandas is gonna take each one of the dates of the month available in that data set, and it's gonna pass me all the rows related to that date of month, one by one. So, for example, let me comment this: print k comma rows, not parentheses, and then break. So, for example, this is only the first iteration of the for loop. The key is 1 because it's the first day of the month, and then it passes me all the days that have all the rows that have day of month 1. Yeah. So you see that there are whatever. So, and then we'll do it the same with the second one, with the third one, and so on. So if I do this, I use this function called len that basically gives you the number of records. Then I can, this is a histogram, this gives you the information for the histogram. It's not very useful though, because I cannot take them and use it. So there are two ways of doing that. I'm going to use a more pandas way of doing it. So define a function called count rows and just return len of rows, and then say by date is equal to data.group by done, and map count rows by date. No, it's apply. So if you see, it's basically the same that we had before. For example, number 4, 26,000. Deleted, but basically just this group by it takes the initial data set and chunks it into groups depending on the date of the month, and then it takes each one of the chunks and passes it to count rows, which just counts the number of rows, and that is returned in a data set that is called DOM, and basically tells you what is the number of records per day of the month. So we can take this and plot it. Oh, it's called by that. And this doesn't look that similar to this, but there are a few differences. If you go here down, for example, this one starts from 10,000 to 36,000. Well, this one starts from 0. Now, the other difference is it has bars, obviously. So we can just use, for example, bar. It tells you the height, so you have to give it the x coordinate. In this case, will be 30. Actually, will be 30 from 1 to 31. There you have it. You see, it's pretty much the same that we had before. You see the same. It's the same plot. Now, what is the advantage of having here is that you can do a lot more other flexible arrangements, and you can take that data and organize it. For example, this is one way of plotting it, but I want to take, for example, this by date and sort it. Sort values. So if you see what happens is it takes it takes the value and it sorts this dataset by the value. So now the order of the dates is out of order, but the values are completely in order. This allows us, for example, to do a nice plot that will be by date sorted. We can just take the same code that we had before. And just plot by date sorted. So now we have the day sorted, but the legend here, that the ticks, they're called, they don't match. So we just have to add them. This ticks and range 131 by date sorted dot index. Sometimes you get a lot of output that's confusing. If you don't like it, just add a colon at the end. And there you have it. You have the dates sorted by frequency of writes on that date. And then you see that the top day is 30, which is easily more than double the average one. And next one is 4, and so on. Again, you can just give it some nice columns, nice labels, and there you have it. It's a very nice and useful plot. Now we can do something similar. Now this is by hour, for example. So analyze the month, analyze the hour. We can use the simple hist data.hour. Again, you have to be careful with the number of pins, otherwise it just doesn't count correctly. So you know there are 24, and still remember that it's slightly off because the bins are not properly centered. So you say range equals 0.5 to 24, and that's better. We have it done. We can do by weekday. I always like adding more because it's convenient. Data.weekday, we know that are 7 days, and then 0.5 to 7, 0.8, color equals green. Yeah, here orange. Well, that's weird. Oh, because this is from -7, -5 to 6. But this is the histogram based on the day of the week. However, we are still slightly off. 6.5. There you go. So you have 0, 1, 2, 3, 4, 5, 6. Now we just have to add the correct ticks. We know that the ticks are, for example, they're located in the same places that this, so range 7, and it will be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And there you have it, done. You can add the rest of the labels and it's ready to go. Sometimes you want to change the color, so you can use some, for example, some HTML color for that, some opacity, and you can play with it however you decide. You can even add the titles and the labels that we added before. Now, so this technique that we use here to do histograms is useful, but it's very simplistic. Sometimes you need to do something more complicated, and for that I'm going to show you, for example, a cross analysis, hour and day of week. So remember that count rows function that we had before, that you give it the data set and gives you a number of rows. We can use that and be a little bit more fancy. For example, if we do data.groupby, but instead of having only one, we have 2, hour and weekday. Then dot apply count rows. Then this basically now allows us to do a hierarchical histogram. So when the hour is 0, you have weekday 0, you have this number, the Monday, Tuesday, Wednesday, then so on and so forth for each one of the hours, for each one of the days of the week. We're gonna call this by hour and weekday, and this one we actually, before, there is a way I like it better, and it's you unstack. You do unstack, then you basically take the second index and you flip it as a column name as opposed to a row name. If you are using pivot tables, you know what this concept means. So now we have the same, but now the weekdays are as columns and the hours are as rows. And this is pretty cool because actually, let's do it backwards. Weekday, an hour. And this is amazing. I don't know if you have tried to do something like this in Excel, but this speed is, there is no comparison. Now we can use a heat map, and let's call this by cross instead, and then here by cross. And look at this. This tells you the frequency that Uber rides were reported given a specific day and a specific hour. You can easily recognize, for example, the weekdays from Monday through Friday, and then the weekend, Saturday and Sunday, because the profiles are so different. You also notice a tendency here to grow up slightly longer, which is interesting to me because it means like Monday nobody goes out, Tuesday and Wednesday, Tuesday almost nobody goes out, and Wednesday there is like a weird thing going on Wednesdays, and Friday everybody goes out, and Saturday is pretty much the same, and then Sunday morning people is still getting home. So this is how simple analysis can be done using Pandas and Matplotlib, which is the plotting library in Seaborn. Let's do a couple more analyses. For example, by lat and long. We can do exactly the same, right? Like a histogram of the data.lat. No, it's not that. It's latitude with capital. Again, only using 10 beans is too little, so if you use 100 beans, remember if you want to remove all this, just add a semicolon at the end. And you see that most of the data is just in this range, between 40.5 and 41. So add a range here, 40.5, 41. And what did I miss? Oh, you have to say equal to. This is interesting, but not that much, because I don't know what those mean exactly. Say with longitude. But the range will be different there. Yeah, the range here is like a 74. Range is equal to negative 74.5 to 70 negative 73.5. You see that there is some weird distribution. Something happens here, something happens here, but most of the bulk happens here. You can get closer to that, for example, 70.1 to 73.9. Yeah, that's a nice distribution. You can actually take, for example, this guy here and this guy here, put it in the same plot, and obviously you cannot see anything because one of the plots is in the negative 70s, the other plot is in the 40s. So you can use string y here to do this, but different colors. Red, color green, alpha 0.5. And there you have it. This is a way to show, in this case, the red one is this with the 70s, and the green one is with the 40s at top. It gets confusing if you have the grid lines, so I'll remove the grid lines here. And there you have it. It's very nice. You can add a legend. There is no legend because you have to call them something. Let's do it here, and let's read label is equal to longitude. Oh yes, you have to add both of them. Locals best. I think this does it. Yeah, it's kind of annoying. Upper right. Okay, let's do here. Okay, finally. Usually I will leave only one of the grids, for example, and that kind of gives an idea of how things work. This is really nice and really convenient and allows you to do quick exploration. Now to finish, now that we have the two plots there, and I told you that this is not very meaningful for nobody because I don't know what latitude means or longitude means. I'll show you something kind of cute. If we plot, plot is just gonna do a typical scatter plot. So data lat is just gonna print the latitude of each one of them. In this case, it prints it as a line. So we can change the limits here, for example, to see the first 100. You clearly see a line. If I don't want a line, I just say use dots instead, and I can change the marker size to something big or bigger or something smaller. This is tiny here, for example. So you can also change the color. Let's make it bigger. And you can change, for example, instead of dots, you can ask for a triangle or a star. That way you can have a few plots that are different. Sorry. Okay, so here is longitude and color red. So it shows you how to do that, right? But remember, the latitude and the longitude are the coordinates of the plot. So you can also do something like data longitude, and then use as a y component the latitude. And this taking a little, it doesn't really show you much. And you see why is just because it has all these lines. So instead of using lines, just use a dot. It still is not very easy to understand. But if you try to make it smaller, and maybe adding some alpha, this is too small. Yeah, so now you can see something, and the reason you cannot see much is because remember initially the histogram has, like when we were doing the histogram, we had like a large range, so you kind of have to zoom in into whatever you care about. So let's zoom in. For example, from negative 74.2 to negative 73.7. Yeah, that kind of some name, but doesn't show much. It doesn't show much because the y limits are also can take to disperse. So y we can just change from 40.7 to 41, for example. And look at that, Manhattan. We can keep on playing with this. So here, for example, something that makes it easier to make it more realistic is just instead of just setting a size of 20, and there you go. This is a really nice plot of Manhattan. You can clearly recognize Manhattan here, Central Park, and you can see here this is LaGuardia. If you go down, you can also see JFK, and a lot of people go see Manhattan. Few people goes to Jersey or Long Island. And that's it. That's it for now. I hope this is helpful, and please let me know if you have any questions.